Okay, last question. This one's pretty tough, pretty long to write out. It's only worth 3 marks, so I would leave it to the very end once you've already done and checked everything else. So what does it do? Design a Turing machine that will take a pair of binary numbers separated by a hash and reverses their order. I mean, this should maybe say and swaps their order. Reverses implies sort of reverse the strings, right? And swaps the order. So I've got 2 strings here. I sort of swap the positions. Okay, so what I'm going to do is basically describe the algorithm I used to do this, and then I'll talk through the solution I actually cooked up. So the algorithm I'm going to use is if you've got some string here, and you've got another string here, what I'm going to do is I'm going to insert a new marker symbol on the left. So wherever I start, assume the tape head's empty, tape head starts somewhere. Okay, so maybe it starts here. What I'm going to do is move all the way to the left and put a new symbol here. And then what I'm going to do is I'm going to copy symbols from the right hand side and move them over to the left hand side. So I go all the way to the right until I see a blank, then move left, destroy the 1, remember that I destroyed the 1, and then put the 1 over here. Move back, destroy the 0, put the 0 here, destroy the 0, destroy the 1. And using a dollar sign is easy because you should keep forwarding until you see the dollar, right? See the 1, put the 1 here. Cool, and then when you get back to the hash, you step after the hash of this blank, that means you're done, right? So then you delete the hash, and you change the dollar to a hash, and then you're done. It's as if I sort of swapped the strings. I mean, I didn't really, I just deleted it and moved it over. But you can't tell the difference if this is the output string, okay? So that's the algorithm I would use. You sort of just take this and you move it over using a new symbol, and then at the end clean up the mess, destroy the hash, and then make the dollar sign the new hash. So here's my pretty Goliath solution that I cooked up earlier. So what it does, this state here basically draws the dollar. This state here moves to the hash. I then check if there's any string after the hash that hasn't yet been moved. So are we in this condition where there's nothing left to move? And if we are, then I delete the hash, I turn the dollar to hash, and then I'm done. And if I'm not, if there's more things to copy over, then I find the very last bit, and then I destroy it. I got a path here to remember the 1 and a path here to remember the 0. This path takes the 1 and goes all the way to the left-hand side and chucks the 1 here, and then it goes back to the move to the hash state, does it again. Otherwise, I delete the 0, and then go all the way to the left, and then dump down the 0, and then reset and do it all over again. You keep doing this until after the hash is just a blank, which means you've consumed the entire input string, and then you clean up the mess. And then there's my little description of what each state does, which is what the question asked. I give a description of the algorithm that I'm executing, and I give a description of each state. But I think if you just label each state, because we can label the states whatever we want, right? So instead of calling them S0 and S1 and S2 or whatever, give them nice descriptive little names. It's pretty clear what find last bit does and delete last bit and replace dollar sign with hash. I think if you just give each state a descriptive name, then you don't need to describe each state because the states themselves are pretty self-explanatory. So that's my solution. Again, it's a pretty lengthy question, so I'd leave it to the end.